Pythagorean theorem. In mathematics, the Pythagorean theorem, also known as Pythagoras' theorem, is a fundamental relation in Euclidean geometry among the three sides of the right triangle. It states that the area of the square whose sides is the hypotenuse is equal to the sum of the areas of the squares on the other two sides. This theorem can be written as an equation relating the lengths of the sides A, B, and C, often called Pythagorean equation, where C represents the length of the hypotenuse and A and B the length of the triangle's other two sides. The theorem can be generalized in various ways, including higher dimensional spaces, to the space that are non-Euclidean, to the objects that are not right triangles, and indeed to the objects that are not triangles at all, but n-dimensional trigonometric functions. In mathematics, the trigonometric functions are real functions which relate any angle of the right-angled triangle to the radius of the side legs. They are widely used in all sciences that are relating to geometry, such as navigation, solid mechanics, celestial mechanics, and many others. They are among the simplest periodic functions, and as such are also widely used for studying periodic phenomena through Fourier analysis. The trigonometric functions most widely used in modern mathematics are the sine, the cosine, and the tangent. Their reciprocals are respectively the cosecant, the secant, and the cotangent, which are less used. Each of the 6 trigonometric functions has a corresponding inverse function. Sine. In mathematics, the sine is a trigonometric function of an angle. The sine of an acute angle is defined in the context of a right triangle. For the specific angle, it is the radius of the length of the side that is opposite that angle to the length of the longest side of the triangle. For an angle x, the sine function is denoted simple as sine x. More generally, the definition of a sine can be extended to any real value in terms of the length of a certain line segment in a unit circle. More modern definitions express the sine as an infinity series, or as the solution of certain differential equations allowing their extensions to arbitrary positive and negative values and even to complex numbers. To define the sine functions of an acute angle alpha, start with a right triangle that contains an angle of measure alpha. Angle alpha in triangle ABC is the angle of the interest. The three sides of the triangle are named as follows. The opposite side is side A. The hypotenuse is the opposite the right angle, in this case side C. The adjacent side is the remaining side, in this case is side B. When such a triangle is chosen, the sine of the angle is equal to the length of the opposite side divided by the length of the hypotenuse. As stated, the value sin alpha appears to depend on the choice of the right triangle. The cosine of an angle A of a right triangle is defined as the ratio between the adjacent side to the angle and the hypotenuse. Cosine alpha is equal B divided C. This reason does not depend on the sine of the chosen right triangle, but is a function of the real angle A, or angle alpha. Tangent. The tangent of an angle is the length of the opposite side divided by the length of the adjacent side. The tangent function, along with the sine and cosine, is the one of the 3 most common trigonometric functions. In any right triangle, the tangent of an angle is the length of the opposite side divided by the...
Hi, I'm Danna, and I'm going to explain how to demonstrate the trigonometric identities. Now we have the reciprocal ones, and we only need to substitute this and this. And this is true because this thing is the inverse of this. So the identity is demonstrated, and we can do the same thing on all the identities. Now we have the quotient ones, and we can do the same thing, but it's a little different. We need to do more things because we have three functions. This one is demonstrated. Now we have the Pythagorean ones, and we're going to demonstrate just this. This is the same function. This one has more steps, so I'm going to delete this later. We're going to do this. Oh no, but first we need to solve this. Oops. Oops. This. Okay. Now we're going to multiply. We're going to solve this. And this is gone. So now we have this. This is the Pythagoras theorem, and this is demonstrated. And this is the end of my explanation.
Okay, let's see your first problem. A person is standing 10 meters away from a tree and it can see the top of the tree from an inclination angle of 30 degrees. Knowing that data, he wants to calculate the height of the tree. So let's do that. Okay, as we can see here we have our original diagram of the problem, and with this we draw our right triangle, that is this one here. X is the height of the tree that we want to calculate, and this side of the triangle is equal to 10. That is the distance between the person that is standing right here and the tree, and the inclination of 30 degrees. Knowing these three data, we can relate it with a tangent function. The tangent of theta is equal to x divided by 10. In this case, theta is equal to 30 degrees. So we isolate the x, we multiply the whole equation by 10, so we obtain 10 times tangent of theta, that is equal to x. We substitute the 30 in our equation, and we obtain that the height of the tree is equal to 5.7735 meters. And that's all for the first problem. Let's go to the next one.
Good afternoon, my name is Carlo, and I will explain an easy way to determine the force is applied in the rope that is pulled in the box using trigonometric functions. First, we can see that the rope has an angle, so this says to us that it has two components. One component in x-axis and another component in the y-axis. In this case, it would be the best if we focus on the y-forces. Okay, let's start. Let's start with the equilibrium equation for y-forces that says to us that the summatory of forces in y is equal to 0. We can see a force in y in the box that is 100 Newton with the direction of down, these forces, and another force in the diagram with up direction, and it's from the component of the force. And that force is 100 Newton to accomplish the equation. But we need to determine the force of the rope and not of their components. For that, we need to use trigonometric functions. And let's calculate the angle with this tangent function. We use this tangent function, and the next step is clear the angle and replace the values we have of distance. For opposite leg is 2 meters, and for adjacent leg is 0.5 meters. And we have a result of 75.96 degrees. Now we can use the equation of cosinus, and let's clear the hypotenuse from it and replace the values we have of the angle. Here is the original equation of cosinus, and here is clearing the hypotenuse. We have a result of 412.2 newtons. And that will be our force of the rope. How we can see, using functions for this is quite easy, and I hope I have explained it well and helped to understand the topic. That's all for my part. Thank you.
Example about force with sinus, cosine, and tangent. Hi everyone, my name is Seini Armando Ramos Durán, and today I'm going to explain some example applying Pythagorean's theorems. First, we're going to analyze the problem applying a Pythagorean theorem. Okay, so the problem is, Blue Demon exerts a force of 10 kilograms on a cart at an angle of 60 degrees from the horizontal. Find the horizontal and vertical components of this force. Okay, so as you can see here, we have the illustration of the problem. Next is the analysis of the problem, as you can see here, to identify the components of the force with an angle of 60 degrees, and the force resultant is 10 kilograms. Okay, In this step, you have to create the free body diagram. Okay, as you can see here. Okay, to determine the calculations to the component horizontal, you have to use cosine of 60 degrees. So clear the equation and the final result is 5 kilograms. To the force in the component vertical, you have to use sinus of 60 degrees. So clear the equation and the final result of the component vertical of force is 8.66 kilograms. So finally, the assortment, you can verify out the results, and as you can see here, are the same. So in conclusion, finally, it's very important to take into account the values of the angles to correctly determine the legs of the triangle in order to correctly apply the Pythagorean theorem and thus obtain the unknown values. So we have with this information that determine the components of the resultant force with applying Pythagorean theorems and sinus, cosine, and tangent. Thanks for watching and have a nice day.